Hello, PreCalc. Here we are with 10.8. This is typically a 2-day lesson. You're going to get the whole video all in one here today. Okay, we've learned how to sketch graphs on a rectangular coordinate system. You begin with the basics of point plotting, and then you use sketching aids such as symmetry, intercepts, asymptotes, periods, and shifts to further investigate the nature of graphs. This section approaches curve sketching on the polar coordinate system similarly, beginning with a demonstration of point plotting. Okay, so we're going to start off with r equals 4 times the sine of theta. And here they've already done the whole entire table for you from 0 to 2 pi, and I think they skipped the pi over 4s. So we can go through and take a look at this. 0, 0. Pi over 6 is going to be 2 units out. 1, 2. Pi over 3 is 2 radical 3. So about 3.5. 1, 2, 3.5-ish, somewhere out there. And pi over 2, we're right at 4. Okay, and then we start coming back in. 3.5-ish. 2, 0. Okay, now it's important to go through and connect your dots every so often because they need to be connected in the same order. And once we start looping around, it can get difficult to remember which dot happened after which dot. So here we go. Alright, so we're to there, and then we're back to 0. Okay, at 7 pi over 6, we're at negative 2, and that puts us right back here. 3 pi over 2, we're at negative 4. Okay, and you can see that we're going to have a bunch of repeated points. It's just going to go around the same circle twice. And indeed, that's what we have, is a circle. Okay, so you can make that table manually if you need to, or, okay, we can go into, oh, this calculator's not going to make it very long. Hopefully we'll make it through this part, at least. Okay, we can go into mode and change it from, degree mode to radian mode, and change it from function over to polar. Enter. Okay, and then also, now when we go to y equals, we'll have this, and we want 4 sine theta, 4 sine, and now our x button's going to turn into theta. Close it. Graph. There it is. It looks like an oval because we are in zoom standard. If you go to zoom square, where it evens it out so it's not stretched or distorted, there's our circle. And let's see, because it's going to be stretched out because before it was like 10, 10, 10, 10, but it's in the shape of a rectangle, so not all the gaps are the same. Okay, in this one you can see it's not 10 and 10 anymore. They've rearranged it so it's more squared up, so all the spaces are equal. We can go second zoom and change from rectangular graph coordinates to polar graph coordinates. And all these things you're going to need to change back if you have a different math class. Otherwise it'll mess you up. And now from our graph we can push trace, and now we can just type in our theta, and it'll tell us our r. So we trace one time, and now we're going to go second pi divided by 6. Okay, and our r is 2. Okay, we can type in pi over 3. Let's see how close we were. Okay, we said about 3.5, and it was 3.46. So there we go. We can use that to go around the loop and plot some points. I'll put that on the charger quick. Onward. We can confirm the graph example 1 by converting the polar equation back into rectangular form, and then sketching the graph of the rectangular equation. You can use your graphing utility. We already talked about changing it to polar mode and to polar graph coordinates. And we'll see that it is a circle. Also note that as theta increases from 0 to 2 pi, the graph is traced out twice. We looked at that, pointed that out. And it's symmetric with respect to the line theta equals pi over 2, aka what we would normally call the y-axis. We have three types of symmetry. We have a vertical line of symmetry where we can reflect it horizontally, theta equals pi over 2. We have a horizontal line of symmetry where we reflect it vertically over it, theta equals 0, the polar axis. And then we have rotational symmetry, where things will be 180 degrees or pi radians away from each other. If your graph involves a sine theta, it will be symmetric with the line theta equals pi over 2. So the line will be vertical and you'll be able to reflect it horizontally. If the graph is dealing with cosine theta, you will have respect to the symmetry with respect to the polar axis and be able to flip it upside down vertically. Okay, let's take a look at the graph of 3 plus 2 cosine theta. And we can use symmetry. Alright, so it's going to be cosine, so we're expecting it to have symmetry here where we can flip it upside down. So let's just get some points up there on the top. So on our calculator, I need to change this one. Mode. I want radian, and I want polar, and I want polar graph. Okay, now we're ready to go. 3 plus 2 cosine theta. Graph. Okay, there it is. This is going to be a little distorted. I'm going to zoom square. Okay. And let's get it going. We can make a table. I know the book does their tables kind of horizontally, and I just make mine vertically. Oh, let's go with, what do you want to do? Every other one? I guess it wouldn't hurt us to go extra here. Let's go pi over 6. Let's just hit all of them. The book skips the pi over 4s when they do their tables sometimes. I guess I skipped it, didn't I? I did. Oh well. We'll just skip it like they did. Uh, 2 pi over 3, 5 pi over 6, and pi. Alright, so trace, 0, enter, 0 theta, r is 5. Should make sense, cosine of 0 is 1, times 2 is 2, plus 3 is 5. Pi divided by 6, we're going to have about 4.7. Pi divided by 3, we have 4. Okay, let's have you go through and fill in the rest of these on your own. And then check back afterwards. Go ahead and pause and fill in the rest of the table there, either using your calculator or kind of mental math there to fill in the rest of the table. Alright, let's see what we got going on. I had these values. And at pi, just a 1. And then we're going to plot these out, and then we'll reflect them over. So 0, we had 5, 4.7, 4, oh, that's 6, isn't it? 1, 2, 3, 4, 5, yep. 4, 3, 2 pi over 3 was 2, and then we had like a 1.3 and a 1. And then we're just going to reflect those over. So that one stays, this one there. One, two, three, 1, 2, 3. 2. Then like a 1.3. All right, we can graph. Hope I missed those two down there on the bottom. All right, you can kind of see it's kind of like a little sideways heart. All right, we'll learn more about the names and the shapes of these here in a minute. Turn the page. Another one to sketch. Another one to sketch, okay? 2 additional aids for graphing polar equations involve knowing the theta values, of which r is the maximum. Where is it going to be the big ones at? And knowing where it is 0. Okay? Sketch the graphs of r equals 1 minus 2 cosine theta. So it's cosine theta. So that's going to involve polar axis symmetry, which means we'll be able to flip it vertically. What's the biggest or smallest? So we're talking absolute value of cosine. Could be 1 or negative 1. So negative 1 times negative 2 would be positive 2. Plus that one out there, the biggest that we're going to have is 3. And that happens at pi, because cosine of pi is negative 1, which then makes this negative 2 times negative 1, positive 2, plus that 1 is 3. That's going to happen at pi. Where would our zeros happen? Okay, 0 equals 1 minus 2 cosine theta. We're going to subtract that 1 over, and then divide by negative 2. So the whole thing would equal 0 when cosine is a half. And where is cosine a half? On our unit circle, cosine would be a half at pi over 3 and 5 pi over 3. So we got a good start here. We got a good start. We can make a little bit of a table. Just with some key points here. You don't necessarily have to use all of them. And pi. Okay, so at 0, we will have negative 1. So 0, you're like, oh, going this way. Oh, nope, negative 1 is going to be this way. Pi over 3, we should be getting 0. So it's going to loop in like that. Pi over 2, we're up to 1. 2 pi over 3, we're going to be at 2. And at pi, we're at our maximum, 1, 2, 3. Okay, so we've looped in like this. Okay, and we can flip these over. And that, those two would just stay. And what's going to happen is we're going to loop like this and back in. And then loop it back in. So again, just plotting these points, and you could do more than this. And again, we can just get those right off your calculator or think mentally about these values. So here's how I did it the first time. I'm just making these little charts. I'm kind of doing the trigonometry mentally and getting those answers. Or you can use your calculator and just type it into trace and get those R values. Another one. We got 4 times cosine of 2 theta. 4 times cosine of 2 theta, what's this going to give us? So it's dealing with cosine. So again, we're going to have polar axis symmetry. maximum value, the biggest thing cosine can be is 1 or negative 1, times 4 is going to be 4 or negative 4. Absolute value, that's going to be 4. Where does that happen at? Where will that happen at? So normally that's going to be at 0, pi, 2 pi, 3 pi, 4 pi. But we have a 2 theta. So it's when 2 theta equals 0 pi, 2 pi, dot, dot, dot. Okay? So to figure out what individual theta is, we're going to divide everything by 2. And now we're going to have all those. 0, pi over 2, pi, 3 pi over 2. It's going to happen at the 90s. Okay? Where do our zeros happen? Oh, 0 divided by 4 is 0. Again, where does cosine normally equal 0 at? Pi over 2, 3 pi over 2, 5 pi over 2, dot, 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 right? But we're talking in 2 theta. So we have to divide those by 2. And now we're going to be at the pi over 4s. So at the 45s. Okay? And if we type this in, 4 cosine 2 theta, it's going to make a rose. It's going to make a rose petal graph. Okay? And for these, when we're graphing them, I'm only going to ask that you get the endpoints. And you kind of, like if we hit this again, like pretend to clear it out, delete, theta, parentheses, and graph it, you can kind of see it loops like this. Okay? So we are at 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So it loops like this. Okay, we could add more points if we wanted to make that a little more accurate. Here are our types of graphs again. If it's anything of the form a plus or minus something times cosine or sine, it's going to be a limacone. If your a value divided by the b value is smaller than 1, we're going to have an inner loop like we did the first time, at the top of this page, I guess. If a divided by b equals 1, we're going to get a little cardioid. It's going to come to a sharp point. What did we have last time? If a divided by b is between 1 and 2, we get a little dimpled one like we did on the front side. And if a divided by b is bigger than 2, it just kind of flattens out. Anything of this form, I guess we lost it there. A times cosine n theta, or a times sine n theta, will make a curve, a rose curve. If the n is odd, that's the number of petals you'll have. If n is even, you're going to have twice that many petals. Sine ones are usually going to be diagonal, and the cosine ones are usually going to be well centered. At least the even ones are going to be centered on the axes. Two new ones. We had a circle. We actually had that for our very first one. And then we had a lemniscate. Okay? And the lemniscates are going to be pretty obvious because they're going to include an r squared. Okay? And again, it's a lemniscates. All these that end up just having like an endpoint and then alternating between like the maximum and 0 and the maximum and 0. We just need to know what the 0 and the maximum. So let's drop on down to this one. We just did a rose curve. If you want to do another one, you can. Let's drop on down to this one. We have r squared equals 4 cosine 2 theta. So we have r squared. So it's a huge hint that it's a lemniscate. 4 is 2 squared times cosine 2 theta. It's a cosine, so it's going to be a horizontal one. We should be able to flip it vertically. So we can type that in. for, actually I don't know if we're going to be able to because it's an r squared. So that might be one we're just going to have to know, because this is going to be a square root of, because we're only typing in r and we have r squared, so we're only typing in r. So we're going to have a positive square root of 4. Let's see if this works. Cosine 2 theta. And then we also need a negative square root for cosine 2 theta. So this is going to do it for us? Kind of. Pretty weak. You can kind of see the figure 8 going on in there. So we have a lemniscate. Symmetry is cosine, so we have polar axis symmetry again. The farthest it's going to be out is a squared, and then this is a, so our a was 2. Okay, so we can go ahead and 1, 2, 1, 2, and it's just going to keep alternating in a figure 8 here. All right. And there we go, kids. The biggest key here is just, if you get stuck, make a table. Use your calculator to come up with those points. We want the maximums. We want zeros. And if you have a crazy one, or like a larger one, like we did in the front, then it's kind of helpful to have more dots along the way, and we can get those off of our calculator as well. All right, thanks for watching. Best of luck. Let me know if you have any questions.